Makes me feel older when they talk about things that I don't know.
Well, that just annoys me. It's like that annoying when toddler is talking about something.
So before I start, we have a quiz tomorrow, don't forget. It's going to be on everything we talked about last week. So that includes graphical limits.
Limits part 2, limits eliminating me.
Limits and infinity.
Limits infinity, is that coincidence?
So this is both infinite limits, like with horizontal, with vertical asymptotes, and limits as x goes to infinity. So we talk about asymptotes. And also limits in reverse. So this is like, if I told you what the limit needs to be, find all the x values that have that limit. Right? That's what tomorrow's quiz is on. There's no normal lesson or anything like that. So if you're not in school tomorrow, you don't have to watch the video or anything. You just have to take the quiz. Any questions on any of that stuff? No? So yesterday we talked about just basic properties of limits that included like adding, subtracting, multiplying, dividing, composition of functions, powers of functions, and then horizontal shifts of functions. Any questions on those properties? All right. So today, we're going to talk about limits from a table. And the idea here is you don't always know what the graph of a function looks like. Sometimes instead of the graph of a function, they might give you an equation. Or sometimes they might give you a table of values or an arrow diagram or some other representation of functions. We have lots of ways to represent functions, right? Or they might just give you a description of the function, okay? So if you don't know what the graph looks like, you gotta have some other way to calculate these limits. And on a table, they're actually pretty easy. Let's look at just a graphical example for a second. Like, suppose I gave you a picture in which we have a function where the limit exists. Like, for example, let's suppose it's just a line that's just missing a single point, like that. Suppose that's what the function looks like. Okay? If I looked at a table of values, and suppose it was a table with an x column and an f of x column, and I substitute in x equals 1, this is going to give me undefined for sure, right? Because there's a hole there, there's nothing there, right? But if I plugged in a number that's really close to 1, it'll give me a number. Like, for example, if I substitute, if this is just the line y equals x, but that's missing a point. If I substitute in, for example, 0.9, it'll give me a number back. It'll give me 0.9. Because this is the graph of y equals x, except it's missing a single point. If I substitute in 0.99, it'll also give me 0.99, and so on, right? If I substituted in 1.01, it'll give me 1.01. Definitely, right? My point is, you can like observe the pattern of these y values and just see that they're definitely going towards 1. If I substitute in a point that was closer to 1 over here, it's going to give me a point that's closer to 1 over here. Same thing going from the right-hand side. If I substitute in 1.0001, that's pretty close to 1. The y value is going to be 1.0001. Again, I can just observe this pattern. I can see that the numbers are getting closer to 1. So just based on the table, if I didn't know what that graph looked like, I would be able to say, just based on this table, that the limit as x goes to 1 from the left of f of x is 1, and the limit as x goes to 1 from the right of f of x is 1, and the limit as x goes to 1 of f of x is 1. Since the left and right limits are both 1, the limit itself has to be 1. Do you agree that that's true?
Yeah.
Now, if I had a function where the limit didn't exist, okay, so let's just suppose for a second that instead of the function looking like that, let's suppose the function looks like this. It's a line, just like before, that's missing a point. But this time, let's suppose that it skipped down to here, and then just continued a line of the same slope like that. Suppose this was f of x. So the first thing, like if this is x and f of x, the first thing is if I actually substitute in that number, like 1, I get a number. I get 0. So it's not undefined anymore, right?
Right.
But if I pick points that are close to 1, it depends on which side I'm looking. Like if I substitute in like 0.9, 0.99, 0.999, these y values are just going to be 0.9, 0.99, 0.999. So just based on this, I would be able to conclude that the limit as x goes to 1 from the left-hand side, since these are all numbers that are to the left of 1, of f of x equals 1, because that's what it appears like this sequence of numbers is approaching.
Right.
But if I went from the right-hand side, like 1.1, 1.01, 1.001, and so on, if I looked at those y values, I would get 0.1, 0.01, 0.001. Just based on my graph, that's what I think I would get. The slope of that line is 1. And so based on this sequence of numbers, where does it appear as if these numbers are headed towards? 0. They're going to 0. So the limit as x goes to 1 from the right of f of x, based on this table, not even looking at the graph, would be 0. So since the one-sided limits are different, 1 from the left, 0 from the right, I would be able to say that the limit as x goes to 1, no superscript, f of x does not exist. Because from the left and the right, I'm going to different places. Does everybody understand the concept? That's how this homework works. They're going to give you a table where you can plug in any x values you want. And you have to plug in x values to determine what the limits are. Let me give you an example from the actual homework. So if I go Delta Math, it's finding limits from a table. So here's a typical problem. They're asking you to find the limit as x goes to -3 from the left, -3 from the right, -3, and f of -3. So the first thing I'm going to do is I'm just going to plug in -3, just to get the last part of this. Press enter, it gives you the value, it's 1. So this value right here is 1. Now I'm going to try and figure out what the limit as x goes to -3 from the left is. What numbers should I substitute in? But to the left of -3, so give me an example. Yeah, like -3.1, -3.01, -3.001, -3. Right? You need to plug in a couple numbers at least so that you get an idea. So I'm just going to start plugging those numbers in. If I substitute in -3.1, I get 1.5. If I substitute in -3.01, I get 1.05. So it looks like there's a pattern, right? Now, if I get a totally random answer, suppose I got 1.5, and then the next one was like 2.7, and the one after that was like -3. Like, okay, so then the limit doesn't exist. There's nothing happening there, right? But these are all definitely a pattern. If I do one more, you can see that it's getting closer to what number? Getting closer to 1. So I'm going to plug in 1 for the limit as x goes to -3 from the left. Then do the same thing from the right. So now I'm going to plug in like -2.9. And -2.99. Oh, I messed up. -2.99. And -2.999. And -2.99999. Okay, what number does it seem like I'm getting closer to? Also 1. So down here, I'm gonna type in 1 for that limit. So what's this limit then? Also 1. If these two are different, then this answer would be does not exist. So you just click on does not exist. But they're the same, so I'm just gonna plug in 1 and then submit the answer. Okay, you gotta fill out all the parts of it. Now, sometimes you might have one. Let's try this one. So this is limit as x goes to -1, same thing. So if I substitute -1, pick 5, so that's here, 5. Now I'm going to do -1.1, and just keep trying numbers, right? Whoops, I'm not doing it right, am I? Oh, 1. Okay. So I get that, and then 1.001, 1.0001. So what do you notice? It's just totally random. So the limit as x goes to -1 from the left does not exist because it's not narrowing in on any one particular value. If you do the same thing with 0.9, and then 0.99, 99, oh, did it wrong again. 0.99, 0.999. All right, what am I doing wrong here?
Should be negative.
Yeah, it should be negative. You clear the table. So I get negative. Okay, yeah. I'm terrible at this. If I just keep doing this, what number does it seem like I'm getting closer to?
It's like 2.
2. So this would be 2. Hello? I do. Yeah, can I give you give it to you in like 5 minutes? Okay. Bye-bye. You gotta go see Mrs. Cleveland when we're done. Okay.
That's fun.
So what would this answer be? Limit as x goes to -1.
Does not exist.
Doesn't exist, right? Because the left limit and the right limit aren't the same thing. So it does not exist. Boom. Boom. Yes. You get the idea? So they're not giving you a picture at all. You just have to sort of formulate a picture in your mind based on these table values. Okay? Any questions on it? All right, that's it.
Can you help me with the page, just a video?